In this video we are going to talk about cross product of vectors and space. The cross product of two vectors, say A and B, gives us another vector which is orthogonal to both A and B. Now look at this example. Here we have A and B as vectors in one plane. Here's our plane. And what we get as a cross product is another vector which is orthogonal to both A and B, as you see. So let's see how we calculate it. Actually, what we do is we write in the first row of a 3 by 3 matrix the unit vectors, and then in the second row we write the values from the component form of A. Alright, we write the component form as the second row, and for the third row we write the component of the vector B. Alright, so this becomes a 3 by 3 matrix, and we calculate the determinant of this matrix. So what we get as a calculation is a 2 by 2 matrices multiplied by the unit vectors. Now let's see how. Let's clean this part first. Now the first 2 by 2 matrix comes from the cancellation of these rows and columns, and the intersection is I, so we write it here, and the remaining part becomes my 2 by 2 determinant. Then I cancel the first row and the second column. Intersection is J, which I write here, and what is left here are two columns which I write here respectively to get a 2 by 2 determinant. And last but not least, we cancel the same row, the first row and the third column this time, which intersects K. We write K here, and the remaining values form my 2 by 2 determinant. Just one important nuance is that you start with this one minus this one plus this one. So the first one is minus, the second one is plus in between. Let's see an example. Find the cross product of U and V given, like here, then show that U cross V is orthogonal, meaning perpendicular to both U and V. Now remember, actually we know that the A cross B is orthogonal to both A and B, but we have to show it. How are we going to show? Remember, if we multiply A cross B, we find the dot product of A cross B and A, and then we find the dot product of course I have to put this in brackets because we have to calculate the cross product first. If we find the dot product of A cross B and A, and separately if we find the dot product of A cross B and B, and if both are 0, then this means A cross B is orthogonal, meaning perpendicular to both A and B. So let's see how. Now first I'll calculate U cross V. So U cross V will be this 3 by 3 determinant, which I can write minus 2, 1, 3, 1, I. Why can I write like this? Because I cancel these two. This is the remaining, and this is the intersection. And then minus 3, 1, minus 3, 1, J, where I cancel the first row and second column. This is the intersection, so I write J there. And these are what is left to me, so that I get my 2 by 2 determinant. Next, plus, I will have 3 to minus 2 minus 3 to 3, say, k. How did I get that? I cancel the first row and third column. This is the intersection I write there, and this is the 2 by 2 determinant I write as my determinant. Now let's calculate. To find the value of the 2 by 2 determinant, we multiply these two minus, we multiply these two. So it will be like minus 2 times 1 minus 2 minus 3 times 1, 3. So the calculation here with the product of I minus 3 times 1, which is 3, minus 3 times 1, which is minus 3. So it will be like 3 times 1 is 3, minus 3 times 1 is minus 3. So it is like that for J, plus here I will again cross multiply here. 3 times 3, which is 9, minus 3 times minus 2, which gives you 6, so it will be 6 with k. When you simplify, you will get minus 5i minus, let's say this is plus, so 3 plus 3 is 6, so it will be 6j plus 3k. So this will give us the component for minus 5 minus 6, 3. This is the cross product of u and v. Now that we have the cross product of u and v, if we go through u cross v dot u, for example, then we are supposed to find 0 so that these two vectors are orthogonal. So let's see. It will be minus 5 minus 6 to 3 dot, what is u? 3 minus 2, 1. Now let's calculate. It will be minus 5 times 3 plus minus 6 times minus 2 plus 3 times 1. So it will be like minus 5 times 3 is minus 15, minus 6 times minus 2 gives 12, and 3 times 1 gives 3. So we get minus 12 plus 12, which is 0. So we say that u cross v and u are orthogonal. Let's find u cross v dot v. So in this case it will be minus 5 minus 6, 3 dot. We'll write the value, component form of v, which is minus 3, 3, 1. So if we do the calculation, it will be minus 5 times minus 3, 15. Minus 6 times 3 is a minus 18, so it will be minus 18. 3 times 1, 3, so it will be plus 3. 15 plus 3 gives you 18. Minus 18, it is 0, so we can say that u cross v and v are orthogonal. Okay, now is your turn. Please solve these two questions. You will find the cross product and you will check if the cross product is orthogonal to both the vectors each other. Stop the video now, solve the questions, and then run the video to see the answers.